Praseeda is the Research and Data Innovation Lead at ASCL, the Center of Excellence in AI and the IIT Alumni Centre, Bangalore. She is the leading initiatives to build robust AI and data ecosystems aimed at driving India's AI evolution through the collaborative research and infrastructure development. She holds a bachelor's degree in information and science from NMAIT Nitte and master's degree from IIIT Bangalore, where she is also completing her Ph.D. Her work spans academia and industry, having taught computer science courses such as data structures, databases, and operating systems at institutes including Sri Devi Institute of Technology, Mangalore, Manipal Institute of Technology, and Institute of Bioinformatics and Applied Biotechnology. She has also worked in corporate sector with Tesco in a data warehousing team. Teaching and learning has been central to her career journey, shaping her passion for innovation in AI education and research. Beyond work, she enjoys trekking, traveling, dancing, singing, and exploring new skills. Presenting works Presenting her work at Samvaad marks a special milestone, fulfilling one of her long-held aspirations from her PhD days. Let's all welcome Praseeda ma'am.
Okay, what do you remember from the Corona experience that we had for about 2 years? Any words, any takeaways? Work from home, okay. Lockdown. Anything else? Two more words. Sorry? Okay, okay. Some coffee, okay. Okay, yeah. So there were diverse takeaways of the same experience which we had for so long, right? Some people remember the crisis, the lockdown, staying at home for a very long time. Some remember the employment disruption that they had. People had to go back to their villages, the struggle that they went through. The mental fatigue, loneliness, a lot of online learning, good or worse, for I'm not sure. And from our research from our lab, as Sir mentioned as well, from Tumkur, the radio recordings revealed a lot of family bonding, time spending more with parents. So the same experience, you had diverse takeaways, and that is what we refer to as assimilation. Uh, Assimilation is now, why do you have diverse takeaways? It depends on who you are, what are you interested in, what you've experienced through, and what what your motivation is. So many factors that would lead to a diverse takeaway and diverse assimilation. So in this research, we explore two main questions. One is students, even when every student goes through the same lecture, and even after this talk that I've presented, each one of you will have a different takeaway. Now, there is, everyone knows this, but is there empirical evidence of this diversity is what we want to look at in this research. The second question we are looking at is, yes, there is diversity in assimilation. So we use standard mechanisms. So far, assimilation is not even represented. So we propose a mechanism to represent this assimilation and how we can understand or take insights from it. So the agenda is first is to understand. So the two empirical evidences that we are talking about, we look at, one is the learner's trace data. That is the activity data in any online learning platform, which we here we are looking at from Guru. The second is looking at diversity in assimilation in the neurological evidences. So we conducted an experiment and captured EEG signals when participants performed something called as conflicting competencies, and we observed the diversity in their assimilation of concepts. And finally, the representation mechanism, we propose a data structure called polylines, which captures this diversity and then map them to a learning map, a two-dimensional progression space to represent these assimilation. Now, what is assimilation? As we explored in the Corona example, the bias in interest, and in this context, we're looking in terms of learning in a specific course. So the bias of learners in as a takeaway from a course. In the case of takeaways, we look at the topics that they are interested in a course. So the course might have n number of topics. Not all topics would be understood or even learned by the learners in the same way. They would have interest in certain set of topics, and some topics they may not even understand it at all. Now, where does this bias come from? It is to do with what their interests are and how their experiences were as well. Now, in case of Corona, you guys mentioned various things. For me, I like nature a lot. So one of the key takeaways that I had was, a lot of animals which were extinct, people were able to track them or find them. And in some places, they were able to see, the Himalayas at a 200-kilometer distance, right? And the second thing that I remember very strongly is the selfless, helpful nature of people, as well as their grit and determination kinds of drives me. So when I saw people walking 300, 400 kilometers just to reach their place, even in whatever situation that they were in, that kind of stayed back with me. But I did not have any experience of family members experiencing issues because of the corona. So that did not stay with me. So it is to do with who you are, what your interests are, what your experiences were, and that drives the assimilation of learners. Now, why is it important that we are constantly talking about assimilation? Now, say I have delivered a course, for a semester. Now, if the learners have not understood those concepts at the end of it, there's no point in, the effort of going through the course itself is not achieved, right? So their understanding is represented through grades, like they get a high grade, low grade, based on the exam performances that they do. So it's not more of an understanding, it's what they call as a proficiency in the course. Okay, but assimilation will tell you, say, okay, now this person in a machine learning course, he's shown a lot of interest in classification. So grouping is something maybe he was very interested in during the mathematics as well. You could track there as well, and down the line, anything to do with classification given in any situation, right? So it could be when you look at genes, genomes, when you look at any sort of data, they would be able to make those groups very easily. So their further trajectories also decides on what their assimilation patterns are, and that's why it is important to understand this. So the first empirical evidence of diversity we explored in the learning trace data. What is learning trace data? You all have learned courses in online learning platforms. You go through various videos. Yeah, you attempt the quizzes. You participate in some assignments, read some notes, attempt some quizzes. So these are the various set of activities that you do through the journey of completing a course. Now that data in terms of the activity, which was the resource consumption, what are the resources that you've consumed, how much time did you spend on consuming these resources, and in this platform, we had the user could give multiple attempts to a quiz. So what they have is, they have data for K-12, which is KG to 12 standard, for 4 different courses: mathematics, science, social science, and English. Now, every activity in the platform is mapped to a competency. So say competency could be adding to numbers. So adding to numbers of integers, adding to numbers of decimals. So each of them are mapped to different competencies. Now for that competencies, they have resources. Okay, this video will explain you adding to numbers in decimal. This video explains, and so on. So they had mapped activities to competencies, quizzes to competencies. So the whole trajectory of how they've consumed these resources and how they've performed in the quiz was there with us. Now, what we did was, we had data for about 28,000 learners competency pairs. Using these 3 features, we predicted if for that competency, the status was completed or in progress. Completed when the quiz value was above 80% score, and in progress if it is less than that. We built an SCM classifier, and we were able to predict this proficiency with 82% accuracy. Now, what we wanted to see, if there is diversity. So to see diversity, we had to build individual learner models. Now for that, we required a huge amount of data, right? So we saw at least if we can get learners who had attempted 30 different competencies and their behaviors, right? How many resources they have consumed, time spent, quizzes attempted, all of that. So we had information like this. A particular user for a particular competency code, they consumed these resources. For each quiz, the status was in progress, and the time spent vector was this. So we collated this where we had, say, more than 30 instances like this. And for each learner, we built an SVM model to predict this proficiency in progress or completed. But the challenge was we wanted to compare the learner models. That is, we wanted to see if there's diversity, if there's no diversity. So to have a uniform model, the features had to be uniform. We were building SVM, which will create a hyperplane, right? So what we did was we saw that the maximum time somebody spent on a resource was about 46,000 seconds. So we converted this resource consumption to a cumulative frequency distribution. What this means is, now in this case, this is one learner's data. For this competency code, at the, so this is 0 second, 100 second, 200 second. At 200 seconds, he has consumed one resource. At 600 seconds, he has consumed 4 resources, and so on. So we had this data for about 459 plus the 462 vector for total 42 different learners. We built 42 different models. Along with that, we built one more average model where we average all this data as an average model. And we had SVM classifier for all of them. So we had 43 SVM hyperplanes. These hyperplanes, since it's a vector, we can cluster them. We used KNN clustering, and using the elbow method, we identified the optimal number of clusters, and here we got them as 6. So, and now we can see, okay, for this cluster, there were so many learners, this cluster, so many learners. One thing which was interesting was this was the average model. It did not cluster with any of the learners' model, right? What does this mean? This is individual learners' model, which can predict whether a learner, given his resource consumption, number of attempts, whether he's in progress or completed. Now, these set of people behaved in a similar way. But the average model did not behave like any of the learners' model. Okay, so that is the first empirical evidence of diversity in learners' assimilation. In the second one, we looked into neurological evidences. What did we do? We proposed to identify something called as conflict. Yeah, sure. Yeah.
So appears, at least from outside, appears that completed or non-completed appears to be a very coarse grain. So any comments on that? Did you try to find out some other output parameters which are more representative of learners' day?
Given in that platform, we did not have much of the data, but there's another study that we'll do with in Sir's course, where we're looking at assimilation. This is not assimilation, very frankly. This is only looking at the behavioral data and looking at observing the diversity in the behavioral data.
Yeah,
that's the crux. Yeah, that's the crux of it.
Before that, before that also, your output state is always completed, not completed.
Yeah, in progress.
My concern or doubt is about that. That sounds like they are dividing the entire student population in a binary classification.
So for one learner, he had, for this competency, he watched these resources. He did so many attempts for this quiz, and he watched these videos for so much time. And at the end, the behavior was it's completed. The same learner, for some other competency, he watched these resources, did these quiz attempts. He spent so much time, but the status is in progress. So for the same learner, I had different behavior. And that I was predicting. The model was predicting that. Okay. That's what That's what I was trying to get at. No, I was just classifying their behaviors. Yeah. Yeah, that's what I was getting at. Yeah, so that's what I said. One learner may have all the form of behaviors. So some set will be completed, some set is in progress. And the model learns that. For another learner, so for the second one, we looked for neurological evidences in a concept what we refer to as conflict. Now, what is conflict? So simple example, earlier Electronic City at least had a particular way in which you could traverse. You know, you could go through to say emphasis from this side or that side, whatever. But now, because of the new rules, you have to traverse in a particular way. Now, because you had traversed in another way for a very long time, by default, your, you know, the handle of your vehicle will turn that way, where you trained well. But then the conflict is where you say, no, I cannot go here because it's a one way now. Okay, so that's a simple understanding of conflict, which is you have a default response, you need to override that default response. And so whatever happens in your cognitive, neurons during that time is what is referred to as conflict. Now, why were we interested, as we all are in the programming space? We have to we have to keep learning new languages, programming languages. Now, most of the books, if you go and see, it will teach a programming language from the point of view of a novice programmer who has not done any programming at all, right? So how do you represent variables and so on? Now, but since I have learned one programming language, when I learn a new programming language, the one which I had already learned prior, right? Those signals in terms of if statements, for loops, structures, semantics, they kind of conflict when I learn the new one. Okay, and that is what we refer to as conflicting competency here. We tracked this conflict when participants did switching between C and Python programming languages, and we captured the EG signals to understand this behavior. So what did we do? We made the participants go through 3 types of tasks: supplementing, conflicting, and non-conflicting. In supplementing, they did all 4 Python tasks. In conflicting, they did Python followed by C, Python followed by C. In non-conflicting, they wrote a Python script followed by some 5 lines of your, so this is an example. So they were given this code snippet, there was logical or semantic errors in them, and they had to comment what is a logical error, what is a semantic error. They were anywhere between 2 to 4 errors. We did not tell them how many are there. And they were given for 4 files, 15 minutes to do the tasks. That was in the first one. The second one, they did Python followed by C. That's the C one. Python followed by C. And the last one, they did Python and say writing activity was write 5 lines about your favorite sport, your favorite teacher, and so on. So this was the experiment. Now, in this case, when you only keep doing Python, there is no chance of a conflict at all. That means you're only doing a Python activity. Now, when you switch from Python to C, right? So that's where they had to comment, right? So the standard is hash is what you use in Python, and // or / and star in C. So so the chances of conflict were in these 3 situations when they were working on these 3 files, right? So to check this, we used our cap from Madhav Rao sir's lab, and we placed the electrodes in prefrontal, frontal, central, and parietal areas, because the literature mentioned that the activity is high in those areas when you do a programming task and you deal with conflict. And we had just 8 electrodes to work with. Now, there were 30 participants who participated in this experiment, 17 male, 13 female, aged between 20 to 29. And they had diverse experience learning when they had learned C and Python programs. Now, the data collected, even though it was 8 channels, 2 channels were derailed for the last 8 participants. So that we ignored those 2 channels. Video grab of the tasks, so when they were performing the commenting, all of that.
participant solutions to the task, demographic data collected prior to the experiment, and feedback of the participants at the end of it. Now, for the basis of this, we had something called as conflict task. Now, what is a conflict task? A simple stimulus response. So say you're supposed to tell the color of the font and not read this. So you're supposed to say blue, red, purple. And that's a simple conflict. But conflicting competency is at a higher level because each person learns the programming language in different ways, right? And it has multiple stimulus and responses within that complete code. So we are dealing at a higher level, but still to see if we are at least corroborating with the literature. So we computed, so for this conflicting task, it's called Stroop test. It's a standard test. It's happening more than 100 years now. Here what they saw was this stimulus where there is a differentiate between the stimulus and the response that you're supposed to override the conflict. There the participants took more time to do the response, right? But so we saw similar behavior in our experiments as well. The average time that the participants took to do a conflicting task, a conflicting competency type 2 task was more. And even their theta activity was also high. That was corroborating with the literature. Now, to observe the diversity, it was hard for us to tell where exactly did the participant experience conflict, because they are doing it for 15 minutes, all 15 minutes, they may or may not even experience conflict. So we had to find markers of that, and we observed the video data. And when those 3 places, as I mentioned earlier, right, when they switched to the C after doing 5 Python tasks, they started with a hash symbol. And then they were typing, but since they were doing it in a gedit, they erased it and then they came back and they started with //. So those timestamps we noted and marked them as conflict experience. That is visual conflict. At least we see there is a marker of that behavior. And when we looked at, this was a distribution. There were around 11 who experienced, did that behavior once. There were about 8 who did it twice. So from C, then again to Python, they did it. And then there were 2, they did it all the 3 times. And there were about 7 who did for none, and 2 whose data we did not happen to collect during the experiment. Now, so we have 6 channels data, and with EG, we know that you have to work in the features domain and not in the raw EG domain. So we extracted statistical features, 10 statistical features for each channel for a 10 seconds interval. So as I mentioned, parietal 2 electrodes, frontal, central, and prefrontal, frontal, central, and parietal. So for 6 channels, we had, for every 10 seconds, we computed the mean, variance, energy, entropy, standard deviation, skewness, kurtosis, Hijoth mobility, and Hijoth complexity for every participant's data. And so now we had 60 features, 6 channels, 10 features for each participant, right? Now, to understand the diversity, we wanted to see if the EG signals can tell when the participant is doing a C activity, Python activity, or a writing activity. Will they be differentiated or not? So we extracted those timestamps because we had the videograph data, and also we had noted the timestamps as well. And we passed those 60 features to a TSNE, which reduces to a 2-dimensional space. Now the red ones are marked with for Python, the green is for C, and blue is for writing activity. For some set of participants, we could see this behavior. What is this? That means their Python, C, and writing activity was separated. The EG signals, the features were able to distinguish, okay, at this time the person was doing Python, and the TSNE was able to show that differentiation. For some participants, there was no differentiation at all. For some participants, the Python was very dominant, while writing and C was merged. And for some, Python and C was merged, and the writing was separated. And if you look at the distribution, the separable, where it was separated for Python, C, and if you corroborate with the visual conflict that we saw, there was not much of a, some people had shown visual conflict, some people had not shown visual conflict. But this was interesting. The ones whose signals were not separable, all of them had shown visual conflict. So this could be considered as a marker that, if your Python C signals are non-separable, that the chances of you experiencing conflict was there. But at least we saw the diversity in their experience of Python C and writing. Now, as I mentioned here, these two, they were Python, right? But this Python came after experiencing 4 Pythons. So there was no chance of experiencing a conflict here. But in this Python, you did it after doing a C activity. So there was a chances of conflict here. We wanted to see if the experience of Python for participants was separable from this and this. They're both doing a code comprehension activity in both these cases. But this was all Python and this was after doing a C activity, right? So to check that, we again use the same features, but for only those instances, which is at first 4 Python and the last 1 Python, and passed it to 3SNE, and we saw this behavior again. For some participants, which is major of them, the experiences were different. So the color difference that you see is because we also tagged motor activity. Motor activity is when they were typing. So we wanted to see if there's some behavior difference in that. But this chunk is when they were doing all the 4 Python activities. This is, so for one learner has done Python activities for a very long time. For 10 seconds, this is the behavior. 10-second behavior of that person. This is one learner's only. Each learners, I got the TSNE separately, and this is the behavior that I saw for about 18 of them. Yeah. In this case, only Python. So this is only Python. This is that Python during the conflict. So this was, but then some of them were not separable. But in this case, that means their experience of Python after going through C was the same as when they were prior. And when we compared that with visual conflict, they did not show any visual conflict as well. Which makes, which is correct, right? They did not see that as conflict at all, and because of which it is not clustered into 2 different things, right? So this was the second thing that we saw. And implication.
What is the interpretation?
Interpretation is, so the Python that they had, comprehension that they had done, and their mental experience during that time, when they were doing all Python, and when they did Python after the C, was the same experience. So they did not experience conflict, probably. That is the only thing.
Yeah, but could you interpret it further?
We don't have any data to interpret it further. I'll tell you why. Because we also asked them to perceive. Ask them to tell whether did you experience conflict. At the end of it, see, the challenge is the experience. Okay.
Your task of same objective. Different for some of them find the same thing, even with the same level of competencies. Some of them find it more difficult, some of them find it less difficult. So that's the variability. Yeah, actually, I have a conjecture.
Okay.
So, for example, when we learn one programming language after another, right? We start building abstract structures in our head. For example, if you have drawn lots of flowcharts before learning the first programming language, I think you are thinking in terms of those abstract structures. And my conjecture is that you would experience far less conflict when you are switching between 2 programming languages, which also is probably true with Indians who are multilingual. We are far better at switching between languages compared to, let's say, Westerners, because I think we have a similar grammatical structure in our head and experience programs. So what I would request you to check is the second variety of graph corresponding to people who were, let's say, more experienced than you.
Sure.
Probably same C and Python SQL instances of SQL.
Sure. But experiencing conflict doesn't mean just difficulty. It's just the default overriding of a standard stimulus that you're trained to. So if if you're trained to switch between programming languages very often, then you can do it very easily. Okay, that is what at least is the crux of it. Yeah, yeah.
So what I am saying
Yeah,
is,
yeah. I'll have to track them now, those participants. Okay. Yeah, and even in the perception of it. So we asked them, did you experience conflict? So there was diversity in that as well. So there were participants who said no, we could see visual conflict of that. And there were participants who said yes, but there was no visual conflict as well. So there's diversity in every aspect of this particular work. Now the last is to represent these diversity in the assimilation. So the standard ways of grades, marks, they just represent it in a single dimension, and it's hard to represent this diversity in a single dimension. So we propose a data structure called polyline to represent the diversity, and we so this is an example of a polyline. So this says, okay, polyline is a multidimensional data structure, and each value in that vector represents the interest or the bias of the interest in the learner in that particular topic. So in this case, it's for maths. So this learner L949 has got a very strong interest in number sense, place value, addition, multiplication, while not so much in measurements. While this person is not shown interest in fractions, measurements, shapes, division, so on, right? So this is the data structure. Now, how do we make this data structure capture the assimilation of learners, right? So right now I asked you about corona, and that's how I got these diverse assimilation. But how do I populate this vector with the assimilation information of the learners? For that, if I ask you a very specific question, right, to today's itself, what was the data structure that we used to do this, to represent this, the diverse assimilation of learners? Somebody told polyline, somebody did not tell polyline. If I just evaluate that question, can I understand your assimilation of this, what lecture I'd given today? No. But if I ask you to tell me, okay, what was your takeaway from this particular class, that summary will give me a more diverse, okay, somebody would take it in terms of mathematically, how do I build models? Someone else might take it in terms of, okay, how do I improve the learning experience? Each of you will explain it differently, right? And that's what we refer to as a constructivist outputs from learners is what we took in the form of summaries, essays to populate this polyline. And so what did we do? Every course has a set of topics that you learn, right? And at what abstraction you will learn that topic will be given by the teacher. You could learn it mathematically, you could learn it conceptually, you could learn it by building platforms and in various ways. So we use those descriptions of the topics, and we represent every learning entity based on those topics. What is a learning entity? It can be a set of resources, which was your videos, audios, assignments, quizzes. Those can be learning entities. The learner's contributions in the form of, say, essays, seminars, summaries, those can be, that will be used to represent the learner, right? And for all of them, we represent them in the form of a polyline, right? Those polylines are then mapped to a two-dimensional space because it's hard for us. So if you say I have these 10 set of lines like this, right? Now you'll say, what do I do with this? How do I understand if somebody is doing better, if somebody is doing worse off? How do I improve so many things, right? So we map them to a two-dimensional space to get those insights. Now, how do we do that? We create embeddings for everything. Okay, so the first thing was a topic. We generate an embedding. We used SBERT in this case. Okay, now these embeddings are used to generate the polylines of everything. So first for topic polyline, what do we do? Say topic T1, I perform a cosine similarity with topic T1 itself. It will be the highest. So the value will be 1. The rest of them will be a value between -1 to 1, which we adjust to 0 to 1. And that's how we get a polyline for topic T1. And similarly for all the topics, and even for learners, we somehow get into this embedding. Now, how do we get? In our case, we used keywords to represent that particular resource or the learners essays because they were very large. SBERT was not doing a very good job, so that's why we extracted n keywords, and from there we generated the embedding to represent that resource or the summary of the learner. And this embedding, again, we performed cosine similarity with all the embeddings of topics to generate again a polyline. Now we have polylines for learners, which are vectors, right? So now what do we do with that? It's hard for us to understand who is high. Now say in this case, one is beautifully covering the other. What does covering mean? The values of this are higher than this in all the dimensions, right? It's not necessary it has to be higher. It has to be at least equal in all the dimensions, but in one dimension, strictly it has to be greater. So say I have another polyline which is same just like this. I cannot say that's covering this. Its value should be at least here, higher than this. Okay, so that is a property we're trying to uphold when we reduce it to a two-dimension space. Now, we could have used standard, we used TSNE earlier, we could have used that. But what do is they see the semantic proximity between these lines in the n dimension, and that they try to maintain in the two dimension. But we wanted to uphold this progression, right? So that's why we used our own algorithm to do this. How do we do this? The two-dimensional space was divided into the n topics of the course, in this case, say 10, okay? And each vector, so the arrangement of these topics also can be decided by the teacher by saying, you know, the easiest topic in the starting and the complex topics can come towards the end. Now, every polyline, we map it to this two-dimensional space. So how do we do it? So say in the initial L949, his values were 1 for all of this. So for topic T1, it will be placed at this position. T2, but for measurements, it was about 0.75. So we correspondingly map 0.75 in this line. And this average is what makes that particular learner's position in the two-dimensional map. For the other learner, last 3 topics were 0. So all those values will be mapped to 0, and the average value gets them into this position. And this is how we map all the learners into a two-dimensional space. Now we'll say, okay, we've created polylines, we've got them into two-dimensional space, now what, right? We'll have to get some insights which so far we were not able to get. So this was done for, so in SIR's Network Science for Web course, we had about 180 students who had written essays for various topics in the course. And we took those essays. We had about 25 topics like confirmatory analytics, information diffusion models, Markov random models. We used those 25 topics to build the polylines for those essays. And we mapped the learners into a two-dimensional space using the algorithm that was proposed. And this is where we have, so the blue ones are the learners, the M145, M008, M142, and the red ones are the orange ones are the resources that is mapped in this two-dimensional space. Now, once we have things in the two-dimensional space, we can get a lot of insights from this. What is that? This I'll explain first, later on. This is locating the learner in the learning space. Since these polylines are vectors, right, we can cluster them. Now, traditional clustering of learners in the class happens how? Whoever has got A grades, A minus grades, 80%, 70%, right? Now, the polylines represent the diversity in interest, right? Can I get some insights based on clustering them? That is what we wanted to observe. And we saw that there were about 11 clusters formed within the course. So we had extracted keywords from their essays, right? We had about 10 to 20 keywords. We used them and extracted top 3 keywords of each cluster. So there were 24 students who got clustered to this cluster. We extracted top 3 keywords and we saw network effect, social network, Twitter structure, right? Somebody else had Simpson paradox, Bayesian network, probability. And in a very broad sense, there were 4 topics like search technologies, machine learning, network analysis, probabilistic models. So if at all somebody asked what were the key takeaways by students in this class, these were the 4 key takeaways that you can mention, right? Now, with this, what happens is, one, the teacher gets an understanding as to what are the students assimilating in the course. Now, do I want, is that assimilation right, and do I want them to go in that way? And even the student can understand, okay, this is the bias that I have as well. All right? So that is the first thing. The second which we saw was, say if somebody has got an A minus grade. Okay, now what do we do about that? Okay, somebody has got A minus grade in this particular course. So, okay, but because of this polyline, we could see that there was diversity in the cluster that they belonged to. So given the A minus grade, I could say that they were interested a lot in image processing, while somebody else was interested in social network and other topics within that. Right? So now you're giving a richer feedback to the learner than just an A minus grade that is happening traditionally. Now, it's a normal challenge for recruiters to find candidates who match a profile, right? Even in our lab, we struggle to get PE students for projects who would, who could work very well for our projects. So because we only have information about their CGPA and their, yes, they do give answers in terms of their interest profile, but a lot of things are not captured in the process. Now, in this case, what we have is, we have the granularity at which a particular learner has behaved in this particular course. So if I'm interested in somebody who's done a lot of programming and has got those skills, I can just observe that parts of the polyline to choose a candidate rather than going through the whole recruitment process. And even we can also create snippets of the job profile or the whatever project elective profile and map that profile to the 2D space and see which clusters cluster to that particular profile. In our case, what we did was we had the social scientist profile that we mapped into our 2D map. And we saw that about 20 students got clustered to it. And based on the grades, AA minus grades, 50 students had got clustered to it. While the other 10 students who did not cluster to it were just had a B plus grade. But because they have clustered to that job profile, that means their interest matches to that profile, right? So because of a grade, they were not shortlisted for it, and those situations can be handled in this case. Yeah, you can ask relevant doubts to teaching assistants. We compared these polyline models with experts, and we saw there was a agreement between the raters, but still there was a lot of disagreement in the basic topics. Like so we passed them 10 essays of students, and we asked them to evaluate across the 10 topics in the course, right? Now, some rater could consider everything as a basic topic, because while some may not. So there was a discrepancy in that, because of which there was disagreement, I mean, not so much of an agreement among the raters. And we compared that along with our model, and as well as ChatGPT and Llama model, and our model fared decently. But then this is a challenge, because even the raters struggle to agree. So this work needs further refinement. Yeah. There's one more use case. So see, anything, if we can represent it as a polyline, we can map it to a 2D map and get insights about the learning, right? So in this case, in the first case, it was assimilation, because we were interested in assimilation, and we did it through getting the essays from the learners or summaries from the learners. But if we also get the proficiency of learners, say across various topics, in this case, it was maths, we will still be able to represent them in a 2D map and get different insights, which was not possible in the earlier case. I'll show you one specific example. So here, Akshara Foundation, they do a Ganita Kalita Andolana, which is a exam to test proficiency in math for 4th, 5th, 6th standard students. We had about 4 lakh students data taken. So they had taken 20 questions, and those 20 questions were mapped to 10 competencies. Now, these questions were also arranged based on basic skills and advanced skills. We had information whether they had got a 1 mark or a 0 mark, 1 mark or a 0 mark for each of these questions. We aggregated them and represented a polyline which represented this 10-dimensional vector for each learner. And then Using our same algorithm, we mapped it to a two-dimensional space. Now, along with this, we also had information in terms of which district, which block, which cluster, which gram panchayat that particular student belonged to. Because they wanted insights at the gram panchayat level, district level, block level, and so on. So we were able to create this dashboard, right? And we were able to drill it into different levels. Now, at the look of it, you can see, this is a polyline. This is a high line. What does high line mean? The highest value among all the set of cohort that you're looking at. It could be a gram panchayat, it could be a district. And there will be, since there's a diversity, there will be highest values is higher and lower is lower. But then if we look at very specific ones, right? So we could see that in this case, these two topics were not learned very well by these set of cohort of learners, which is very evident just by looking at the polyline. And the interventions can be provided then and there, right? Because of this form of representation, now in this case, this is a 45-degree. Whatever is below the 45-degree is the students are good in the basic skills, but may not be strong in the advanced skills. Okay, and if we have a lot of participants above the polyline, above this 45-degree line, then they're good at the advanced skills and not good at basic skills, which again begs the question why. Okay, so such insights can be got very easily, and this one was very interesting. These two students had got the same marks, 10 marks, 10 marks itself. Now, given that somebody has got the same marks, the feedback is going to be the same by the teacher. Okay, work on this, work on that, something of that sort. But in this case, the first person had this as a profile, while the second person had this as a profile. Now, because they're situated in two different places, the feedback is going to be should be different. And because of this, we are able to track those cases and provide proper feedback as well. So that was one. And the second one, use cases we saw with IMTech students here itself, not sure of which year. We took their first year marks, grades in the 6 subjects that they had, which is programming in C, programming in Python, English, economics, digital design, and what was one more? Mathematics, right? And we represented them as polylines. Now, we saw that if we just see the high line and the low line, the economics low line is very high. That means the students, the minimum grade that anyone got in that course was B+. There were no failures or even C or B as well in that course. Apparently, I was told it's that is how it is. But then, interesting part about it is when I just took, say, A minus A grade profiles, right, and students, and I observed their behavior of the students over there. There were 2 distinct profiles that we came across. One was, see, they had programming in C, programming Python, mathematics as one combination. They were very good at that. And the second one was mathematics, programming, and English. They were very good at. Now, it would be interesting if we can track their journey and see what courses that or what specializations that they would do down the line. And will polylines be able to track their? I mean, if we can use polylines to track their changes, also it'd be great. And also to even suggest, okay, this could be something that you would be doing down the line as well, or do you want to do it? This is what at least it tells us about. So that is the utility of the map, and yeah, this is how we are representing it. So we have our portal guru.tripleit.ac.in, which is up most of the times. You can check for it. We have done a discrete mathematics course by the professor here from the NPTEL, and we've represented them in a 2D map for learning. So the key findings of this research is that diversity is real, and we have shown empirical results for that. We have represented this diversity of assimilation with the help of polyline and then map them to a 2-dimensional map. And this can further, so right now we've built the groundwork, right? We have mapped resources, we have mapped learners, we have mapped topics into a 2-dimensional space. Now we can build so many things. This is like a Google map where every entity has been mapped into the space, right? You can build pathways, you can build what are the most favorite, topics or most favorite concepts or most favorite maybe job profiles people are looking at. The limit, I mean, there's no limit for it. It can always grow from here. Yeah, there are several limitations. One is, I mean, at least we want to work towards further is to test the learning map in a real world scenario and see the utility of the map. How is it helping the assimilation? And if it's possible, integrate this map with the existing MOOC solutions itself to provide that insight to learners and teachers. Maybe create new constructivist activities, like how do you represent, map a code that a person has written into a two-dimensional polyline, polyline and then to a two-dimensional map. And or say in a larger domain like skills, how do you even capture the skill and then map it to a two-dimensional space. Yes, so this is where it is in the applications. Thank you. Any questions?
Like you were showing learner polylines, suppose let's say for that it's around 25 topics, let's say. If the learner polyline for one learner completely covers the polyline for another learner across all the topic assimilations, can I say that the learner one is better learner than learner two? Assimilation.
Assimilation talks about interest. Now, better you'll have to define metrics for it. What do you mean by better? Interest cannot define somebody's proficiency, so you may have to use that as well. I can know a lot about it, but if I don't do anything about it, I'm not able to do work with it at all.
Let me rephrase it. Like, can I say that if the polygon of learner one completely covers the polygon of learner two, so learner one has the highest takeaway from the course than compared to learner. Can I say that? He has done the most takeaway.
I don't know how to define that. If you can define what is a takeaway. So see, somebody can have a takeaway about only certain set of topics itself in a very deep fashion. And somebody could have taken an average understanding about everything within the course. So there can be, so far in our research, we only say there's the diversity. Now, what is a takeaway from that? I am not sure.
Limitations of what kind of assumptions have been there in the process. Maybe there might be a possibility that those assumptions don't work.
See, one is to validate this model. So say, okay, this particular person has written about an essay. Now this essay, he is talking more about this topic rather than some other topic. And in a glance, we could see, okay, the model is behaving well, but is it so for each and everything? It's really hard. And what happens is, first we're using an embedding, which is about 600 to 700 dimension. Then we're reducing it to say 10 dimension. So then a lot of averaging was happening in that case, because of which the polylines were not, I mean, they were showing differences between topics, but not to a great extent that we could use the map to show that diversity very well. So we had to do some tweakness. Sorry?
Just because it is
we were not able to see the diversity in the map, is what I say. So we.
that's what. See, if you zoom, you can see the diversity. So how do you know what it is? Like there is diversity among, but can you see anyone with two heads and six hands? No, it's possible. Maybe it's so of course you don't see that. So what possible values will not be. What is the correct extent of?
I don't know that to determine as well.
Especially the summaries to assume that they are thinking that topic, they're not capable to something.
That's the question that everyone asks. What do you do if there's
Summarize, then you get the assimilation pattern.
the learner. So that is a challenge in any online learning. One is this model always needs a human in the loop. So in the in our this as well, we have a provision where where the learner summarizes his learning and the teacher gives a grade accordingly. So then they would say, so a human in the loop approach is always required. Now, yeah, the teacher is also smart enough to understand whether it's a chat GPT one or the student has written as well. And in that case, they can tweak it accordingly. They can give a grade for that particular those are challenges as well, and it is also in a classroom setting as well, right? So the teacher, whoever answers always, that person would be like, okay, this person will always get a leverage compared to the ones who doesn't answer because of the confidence. So that is a confidence issue in a classroom setting. There's also a language issue when somebody writes as well. So those challenges will always be there when you're taking summaries and essays.
Then you're more likely to repeat because there are consequences. Maybe then I should say then all this. I think there is also a recognition of engagement. The large classes, that is a common thing, right? So everything short of a somersault to attract the attention of the students in class. But there will be students who will doubly, decidedly not engage. To ask questions, crack jokes, insult them, praise them. So these are dispositional angles. They are deeply seated with the person's background. The person approaches education from a very adversarial point of view. Whenever times you say that, I'm trying to make you learn, or I'm trying to make you learn, they will always take everything you say in a cynical way. They will not engage. So I think even however once you make the poster demonstrative, very diverse, large group, very hard to go. Completely depends upon the effort. We think that this is more than effort I am ready to put, especially because it's not really lot of grades. Another thing is, so one question, so is there something actionable or not actionable because what can it be?
See, it's hard for teachers to understand the diversity. Now, given this platform, we're trying to conduct an experiment now in a classroom setup where the students give, say, summaries or some of their takeaways from, say, after each class. Summarize your learning, something of that sort. And that, if the teacher can understand, okay, what were the key concepts that most of the students have, some set of students have take away these concepts. If they could get that as a cluster for the teacher, then they can understand whether that was the intended takeaway that they would want to, and how they would want to engage further, or they were even so. First, with assimilation, what we refer to is the correct understanding, but with the summaries, we can also get those wrong understandings as well. So that can be the first point of feedback for the teacher to work on. And the second thing is even to get a sense of which are the topics that they are struggling with as well. So from the summaries, we'll be able to identify that, and that the teacher can focus on in the class. So yeah, this is, so here they write a summary. They'll have to write whatever is the topic. So this is district maths course by Ashish Chaudhary sir's NPTEL course, which we mapped it into a 2D map right now. And the these are the videos from the YouTube that we had taken. So the current, this guy is a learner. No, that is a TA. This is a TA. Where did the learner go? He is a learner. The learner is way up. This is, no. Is it? Okay. No, the name has to be worked out. Yeah, there's a cap, I think, in this thing. There was a cap. Anyways, okay. Some version got published here, I guess. So the learner, that's what. So there are some quizzes that they can attempt to, and they can see their polyline, and a teacher can see that for all the learners, how they have progressed. So this is the list of how their polylines have moved through various contributions. They're normal. So this we are done for these two courses, and we're trying to do an experiment for foundations of AI right now. But yeah, the cluster part, we have so far, we have done it only in Tableau. We'll have to add that here. And that could be that one feedback, and to see how each learners are. So the teacher can see all the learners. In this case, the learner can see only themselves. There's no incentive. So what we are saying is there are multiple endpoints within the course. That means you can be expert in certain set of concepts. So how will you, the challenge is the learner would not know giving what response will make them go to that particular position. So that's at least it's not so deterministic for them. So